Good morning, this is your Stat Sensei, Mr. Spensei, and this is the Death Packet, Unit 2, displaying and describing data. And this is our next video, and this is problems 31 through 40. Problems 31 through 40. If all the values of a data set are equal, all the values must equal 0 except for which of the one. Well, how about this? If everyone made an 80, the lowest minus highest would mean my range would be the same, would be 0. My interquartile range, Q3 and Q1 would be the same. There'd be no variation, there'd be no standard deviation, but my average would still be 80. So in which case the mean didn't change. So the one thing that would have to be not have to be 0 is the mean. Now, if they're all 0, if the values were 0, then the mean would be 0. But if everyone made an 80 on the test, there'd be no standard deviation, no range, no IQR, and the average would be 80. Okay, so that one's A. Which of the following, number 32, which of the following is a true statement? If the sample has a variance of 0, the variance of the population is also 0. No, it's possible that we had, this is what if our population looked like this? 0, 0, 0, 0, and then had a 10. Well, it would be possible, obviously, if I had a 10, then there's no way my variance is 0 because it's different. But in this case, my sample, I could have drawn 2 zeros. So no, that's not possible. If the population has a variance of 0, then the sample also has a variance of 0. Well, that means my population had to be the same number all the way across. And if my population is the same number all the way across, then my sample must also have the same. And so if the population has a variance of 0, then everyone in the sample would also have the same value, in which case there'd be no variation and it would be 0. So B is my answer. Given the two histograms, which of the following is correct? Both sets have the same mean. I don't know where the mean occurs. It could be anywhere between here and here and here and here. So I don't know exactly where it occurs, so it can't be that. Both sets have the same median. Same reason. I know the median's somewhere in here, but I don't know exactly where. Both sets have the same range. Well, what if it was up here at 14, or this is up here at 14, and this was all the way down here at 46? I go, oh, 46 minus 14, that's 32. So that would mean this one had a range of 32. And this one is at 10 and at 50, in which case you go, oh, that has a range of 40. So because we don't know where in the bin the value actually is, it can't be that. Set A has a greater variance than set B. And in this case, we're more spread out. The more we have on the data we have on the ends, the more spread out it is, the larger the variation. This is kind of like this one. The more dots I had in the center, the smallest variation, the smallest standard deviation. This one would have had the most because it is the most spread out. Number 34. Which has the larger mean and which has the larger standard deviation? All right. So, well, distribution 2 definitely has the larger mean. So let's work with the larger mean. That gets rid of A and B. Now, standard deviation is the measure of spread. Well, this one is more spread out. So distribution 1 is more spread out. So that means distribution 1 has the larger standard deviation. So larger mean was 2, larger standard deviation was 1, because this one is more spread out. All right. 35. Which of the following measures are most likely to describe the center and spread? Well, when I look at this, I'll go, oh, this is skewed. If it's skewed, we like to use the median and the interquartile range. So we don't want to use mean and standard deviation because it's impacted by skewed data. The interquartile range is a good choice, but the mean isn't. The mean and range are poor choices. The median and interquartile range, best choices because it's the middlemost number and the middle 50. So the middle part is not impacted by the skewness. It's the ends that are. All right. And which of the following is the mean less than the median? All right. So when I look at this one, the mean and median should be pretty equal. Mean and median pretty equal. Mean and median, oops, that mean and median are going to be pretty equal in the center. Now this one is skewed right, which means my mean will be greater than my median because if this is my median right here, my mean is going to be somewhere up above it. This one is skewed left, which if this is where my median is, my mean will be to the left of it. So skewed left, mean left, and basically this, if this were 0 and this were 100, the mean would be less than the median. So our answer choice for this one is E. Given the histogram of test scores above, which of the following is a true statement? All right. So the median score was 75. Well, how many boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the median score, if we have 18 boxes, should be about at the ninth box. So 1, 2, 3, 4, 5, 6, 7, 8. So it would occur right about here. So about 85 as opposed to 75. If 90 and above are an A, most students received an A. And you're like, oh, hey, you know what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're like, hey, that's my answer. It's like, no, because this goes down to 85. We don't know how many people are in the below 90 in that 85 group. More students scored below 70 than above 90. Well, we know for sure that 4 scored here and 1, 2, 3, 4, 5. So that's not true. More students scored above the median than below the median. That's always false. That's going to be 50% above and 50% below. That'll never be the answer. The mean score is probably less than the median. Well, if I were to fit a curve to this, it looks like it's skewed to the left. If it's skewed to the left, the mean will be less than the median. The median is going to be about here. The mean will be somewhere over here. So E is my best choice. All right, the 60 longest rivers in the world have links distributed as follows. Which of the following best describes it? Well, if I were making a number line of this, I would go, hey, I got a whole bunch in this category and only a few down here. That means it looks like it is skewed right. All right. So in this case, skewed right. And if it's skewed right, then the mean is going to be, well, my median will be over here. The middlemost will be somewhere over here, the median, and the mean is going to be to the right of it. So the mean will be greater than the median, and it's going to be skewed because I have a whole bunch at the beginning and not very many in the tail. All right, if you ever get one of these, you almost never have to input the data. You can kind of look and see what's going on. All right, so two random samples of students are chosen. For one from those taking an AP statistic class, and one from those who are not. The following back-to-back stem plot compare the GPAs. So these are the GPAs of AP stats. These are the GPA of non-AP stats. And we have 1.8, 1.9, 2, 2.0, 2.1, 3.1, okay, 4.0, 4.1, 4.1. So the first set has both a greater range and a greater standard deviation. Well, I'm looking at them and I'm going, you know what? This one is centered. All right. And because it's centered, I don't think it's going to have a greater range. I mean, a greater standard deviation. This is definitely skewed. All right. If it's skewed, this will have a greater standard deviation. So that's not it. The first set has a greater range, while the second set has a greater standard deviation. Well, that's possible. All right. So with that said, my smallest value is 23. My largest value is 41. 41 minus 23. That's 18. This is 18, and this is 38. So 38 minus 18 is 20. So this has the larger range. So that's not it. It has a larger standard deviation and a larger range. The first set has a greater standard deviation. Nope. We've already discussed that. If it's reasonably symmetric, it'll have a smaller standard deviation. The second set has both a greater range and a greater standard deviation. That's true. We know it's not symmetric, so it'll have a greater standard deviation. And we already calculated the range. This had a range of 20. This had a range of 18. 20 is greater than 18. D's our choice. All right. Which of the following statements is incorrect? In all normal distributions, the mean and median are equal. Oh, that's a true statement. Why? Because it's bell-shaped and symmetric. And if it's symmetric and bell-shaped, mean and median will be the same. It's not because it's normal, it's because it's symmetric. A normal distribution is completely determined by two numbers, its mean and standard deviation. That's a true statement. You didn't know that because I didn't talk about it. All bell-shaped curves are normal. Nope. All bell-shaped curves are bell-shaped. They are mound-shaped. They're a bunch of distributions that are bell-shaped, and not all of them are normal. All right. Thanks for watching. Hope to see you on the next one.